Artemis 1 is go for launch as NASA completes the flight readiness review. An American deorbit vehicle for the ISS is under consideration, and SpaceX reveals plans to launch its next-generation satellites on Falcon 9. All this and more on today's WSN Space Newscast.
Three, two, 1, 0.
Now, here is World Spaceflight News Editor, Randall Schutler.
Greetings and welcome to the inaugural edition of the World Spaceflight News Space Newscast, where we feature comprehensive and wide-ranging coverage of the exciting developments in the second golden age of space travel. This is the groundbreaking home for unique news and fresh perspectives to complement the usual media sources and YouTube channels fueled by lifelong space enthusiasm. If you'd like to know more about our work and plans for this channel, please check out our introduction video. As we gain experience, we will be refining our production and adding many unique features, including science and history videos. We're just dipping our toe in the water, exploring the vast wealth of news material that frequently gets overlooked. Because we need to produce these newscasts on a very short turnaround time frame, don't expect them to be quite as polished or fancy as those made by others on a less frequent schedule. Small studio, cosmic goals. Of course, for the next 2 months, our attention will be firmly riveted on the Artemis 1 flight, along with progress at Boca Chica toward the first launch of Super Heavy and Starship. But that won't stop us from covering the other important stories that happen every day. We hope to become your essential source of diversified space news throughout every week. We'll have much more about the surprising NASA interest in a deorbit vehicle for the space station a bit later in the broadcast. But now we turn to the historic story of the Artemis 1 launch. Artemis is go for launch after NASA concluded its all-day flight readiness review meeting on Monday. In evening press briefings, NASA officials were keen to stress the experimental nature of the flight and discussed the risks inherent in the first launch. Gone was the talk of the mega moon rocket. They offered lengthy explanations of goals and alternate missions that might be invoked should anomalies prevent completion of the flight plan. It was a sobering and realistic presentation that set the stage for the much-anticipated launch attempt, aiming for liftoff at 8:33 a.m. Eastern Time next Monday. Here are the key excerpts from that briefing.
That I want to put this in perspective. This is a test flight, all right? And it's not without risk. We have analyzed the risk as best we can, and we've mitigated it also as best we can. But we are stressing Orion beyond what it was actually designed for, in preparation for sending it to the moon with a crew. And we want to make sure that it works absolutely perfectly when we do that, and that we understand all the risks. We're going to learn a lot from this test flight. There are certain cases that could come up that could cause us to come home early, and that's okay. We have contingencies in place, and the main objective that we really want to get out of this test flight, of course, is that stressing that heat shield, getting a test of that new Orion heat shield at lunar reentry velocities. So,
as Bob talked about the risk, we are pushing the vehicle to its limits, really stressing it to get ready for crew. It is incredibly risky. We talked about risks today. We talked about our mitigation steps for those risks. And we've mitigated the risk as far as we can, and now it's our time to get to launch so that we get that data that we need to put crew on it.
In terms of the mission management team, which I'll be chairing when we get to pick up at the Launch Minus 2-day review, which is essentially our launch readiness review, we have a series of decision gates that are in front of us. And the purpose of the mission management team is to provide oversight in risk acceptance, as well as to basically, if we are outside of our pre-planned criteria, to assess whether we should continue or whether we should knock it off as part of a flight test. We do have a series of checkpoints built into the mission, and we've trained those alongside of our operations teams, our launch team, our flight team, and our recovery team, as well as with our engineering support elements in Huntsville and in Houston. The test flight itself carries inherent risk, and we talked about that today. We talked about what we call moderate risk and high risks throughout. This is the first flight of a new rocket and a new spacecraft, and at its furthest point, the spacecraft will be nearly 290,000 miles from Earth before returning home. And this is the first human-class mission in over 50 years. So we're doing something that is incredibly difficult to do and does carry inherent risk in it. I guess one thing that I've been reflecting on today was a quote by Hugh Dryden, who was one of the founders of the Apollo program, and he talked about the purpose of flight testing, which was to separate the real from the imagined and the known from the unknown. So that's what Artemis 1 is all about.
As has been mentioned in previous press briefings, we have extended the time frame of our flight termination system that is required by the Space Launch Delta 45th to cover 3 launch attempts. I wanted to mention that since that was a change since we met last time. And then also we have finished up all of our launch team training. We've completed 30 sims, so our team is certified and ready to go. So we are on plan and certainly looking forward to call the stations coming up on Saturday.
The next steps will be we'll finally open up the hatch one more time, install the final our zero-G gravity indicator, Snoopy, so that'll be really exciting as well. We'll do final closeouts where we'll pull the soft covers from the windows and the seats and things like that, and we'll be ready to fly.
So now it's time for the big test of all. It is the combined environments test and flight. It's a test that we can't duplicate on the ground. We've tried our best with all the environments we have, but this is the reason we fly, to fully understand the vehicle. So we're excited about it. At the end of the day, we went through all the polling. The team is ready, the rocket is ready, and we're here to support.
It was designed for 21 days, and that's what the European service module was certified for. Going 42 days puts a lot more stress on all those systems, plus the environment that it's in. Longer exposure to radiation, longer exposure to micrometeorite hits. We're going to learn a lot from this test flight. And the point is, we're stressing it beyond what it was designed for.
You stretch out the duration, the environment that you're going through on the 1.5 revs that we're going to go through on the DRO, that'll allow you to test out the systems fully as you go through that time frame of 42 days. And so that duration, along with, we're really trying to activate all the systems utilized, for example, optical nav. We're pushing the optical nav technology and be able to certify that for future flights when we don't have comm on the spacecraft potentially, and utilizing that as a navigation asset. So those are things that we're looking forward to in terms of demonstrating capability and pushing the envelope of the technologies that we have on board the spacecraft.
So on Artemis 1, we have a lean forward strategy to get our high priority objective, which is to demonstrate the heat shield at lunar reentry conditions. We are going to press to the point of translunar injection unless we're sure that we're going to lose the vehicle. So we've got a lean forward strategy here on this flight. We would be go on this flight for conditions that we would normally be no-go for on a crewed flight in the interest of crew safety. But because we want to buy down risk across the manifest and to understand this system and the system design and its margins, we are going to press through the point of translunar injection if at all possible. In terms of aborts, the vehicle is largely automated from the point of booster ignition all the way up through translunar injection. And we've got go-no-go criteria that have been established at various points along the way, including the translunar injection maneuver. And then we have a couple of gates prior to the translunar injection maneuver, as well as prior to the perigee raise maneuver. And we could punch off the interim cryo propulsion stage while it's in a inhibited attitude control system phase. Those bars are set pretty high. We would only do that if, again, we were pretty sure we would lose the work. So that is something that is unique to this uncrewed flight test, and we're going to press ahead and press uphill unless we're sure we're going to lose it. I don't know. Probably the biggest one that was talked at our flight readiness review today was the hydrogen kickstart to thermally condition the engines. If you recall, coming out of the last wet dress rehearsal, that was the one open item that we had, and that is the one open item that we have headed into this launch countdown. And Charlie and her team have come up with a plan to demonstrate it before we get into terminal count, and that is something that we're going to demonstrate end-to-end for the first time on day of launch. And if we do not successfully demonstrate that, we are not going to launch that day. And I don't know, Charlie, if you have anything to add on the hydrogen kickstart.
No, I think you covered the hydrogen kickstart. We did, what we'll do is we'll plan to put that in after we get core stage LH2 or liquid hydrogen into replenish. And we'll close the vent valve on the core stage. That puts some pressure on it. We'll go and verify. First off, we'll verify the functionality of that 4-inch QD where we had the issue during wet dress rehearsal, verify that that's working correctly. Once we have a predetermined amount of kickstart bleed, it's about 45 minutes or so, and then we'll get into a vented bleed, and then after that we'll do the special pre-press test. Normally that would happen in terminal count. We would have done it in wet dress, but we weren't able to do that because of the issue that we had, and so we've added that into the launch countdown at a kind of a quiescent point, if you will, so that we can understand that prior to getting into terminal count, where you have a lot of other dynamics in your system. And then with regard to other open work, I would just say from a pad flow perspective, we are really down to those two tests we talked about. We'll get into those tomorrow. One is we'll go through and we'll do our safe and arm rotations. We have already completed, Howard talked about the late stow work that we did this weekend, the Orion hatch closure, and so that's behind us. So now really we're just looking at that RF testing, the safe and arm rotations, the booster servicing, and then getting into our launch countdown preps, and then into launch countdown proper. But all of that work is very, very well choreographed, laid out, and again, very consistent schedules with what we had going into wet dress.
Yes, we have 10 CubeSats on this flight. We talked at the flight readiness review today. 5 of those have been essentially topped off in terms of battery state of charge. We've had open communications with each of the CubeSat customers as to access and just design constraints all the way up through the install on the vehicle. Prior to that, we had the payload safety review process, and we are at the point where we're getting ready to fly. The remainder of those CubeSats, we, based on analysis, believe have sufficient charge to conduct a mission. Some may actually need to recharge after they're deployed, after they gain some solar power through their solar arrays, but we believe each of these has a mission. That said, the CubeSats are relatively low cost. They have relatively low levels of redundancy and a relatively high failure rate. So we do anticipate one or more of these CubeSats to not be successful in its mission, just due to the nature of the CubeSats themselves. We've put considerable planning and effort into what we call alternate missions, and we're going to go as high as we're able to within the consumables and the systems that we have. If we have a performance problem on the rocket, we're going to fly as far as we can, and there are cases where we can try to make some of that up with either the interim cryo propulsion stage, the upper stage, if there's a core stage performance issue. And then there are other cases where we may be able to complete the translunar injection maneuver using the Orion spacecraft and its service module. So from an integrated performance standpoint, there are scenarios where we'll fly as high as we can. If we are uncomfortable for whatever reason, performance or systems-wise, with entering the distant retrograde orbit, we have alternate missions that would allow us to downmode to a lunar flyby. At translunar injection, we are not targeting a free return trajectory, but we could adjust to downmode to a free return trajectory about the moon. And then if we didn't have enough performance to do a lunar flyby, we could do a very high elliptical orbit and go out as far as we could towards the moon and come home. Or we could do a high Earth orbit, or we could do a low Earth orbit. So depending on the performance margin available and depending on the systems problem, we could fly as high as we could. And that's part of our alternate mission strategy. In terms of pushing Orion, one of the cases that we've talked about is a failed solar array deploy. If you look at our timeline, we normally separate from the core stage, we deploy the solar arrays, we do the perigee raise maneuver, and then the translunar injection maneuver. If we had a failed solar array deploy, we would proceed. And that is something that we wouldn't necessarily do on a crewed flight. There are a number of other systems that we've agreed to proceed forward with, and we could be zero fault tolerant. We could be on the last remaining string of our guidance and nav system, on our propulsion system, on a whole host of other systems, and we would proceed through TLI.
NASA has taken an important step towards developing an American capability to deorbit the International Space Station. It's an especially welcome development considering the fraught geopolitical environment that has seen the Russian space agency threaten to withdraw from the project and allow an uncontrolled and highly dangerous re-entry. On Friday, NASA posted a request for information, or RFI, to get industry input on providing deorbit capabilities. It isn't a full-fledged request for proposal, rather it is the first step in the process. At this point, we don't know if the initiative came from within NASA or has been encouraged by the Biden administration or congressional input. The Russian invasion of Ukraine and the subsequent tensions have provided ample reason to build an independent propulsion module. It seems likely that SpaceX and Northrop Grumman are in the best position to supply this important vehicle. The document states, "The deorbit vehicle shall attach via docking or berthing to the ISS at least 1 year prior to the planned ISS reentry date to enable adequate time for on-orbit tests and checkouts. ISS altitude lowering can occur naturally via atmospheric drag or via Russian propulsive control from the deorbit vehicle rendezvous altitude to the final circular holding altitude at approximately 270 kilometers or 168 miles, where maneuvers will be performed as necessary to establish proper ground tracks prior to the final deorbit burn sequences. Below 270 kilometers, a combination of natural decay and/or propulsive maneuvers will reduce the ISS perigee to approximately 150 kilometers or 93 miles. Shortly thereafter, the deorbit vehicle will perform its final reentry burn, resulting in a controlled reentry of the ISS within a predefined, uninhabited entry corridor. Throughout the final series of deorbit events, the deorbit vehicle will be responsible for providing both delta V and attitude control of the ISS. Although nominal ISS end of life, EOL, is late 2030, the government requires that this deorbit capability be available as soon as possible to protect for contingencies that could drive early reentry and beyond 2030 in the event of further ISS mission extensions. The request also discusses the possible use of the vehicle in future commercial LEO destinations. Looking back at the history of disposal plans, in January of this year, NASA reported that 3 Russian Progress spacecraft would be required for the ISS deorbit maneuver, and an evaluation of the expanded propulsion capabilities of the Northrop Grumman's Cygnus resupply craft was also being conducted to see if it, quote, could be part of the vehicle capability needed, unquote. In the late 1990s, NASA worked with the Naval Research Laboratory to build the Interim Control Module, ICM, as a contingency substitute for the Russian Zvezda service module. The ICM was based on a propulsion component called the Titan Launch Dispenser, used by the NRO to place classified ocean surveillance satellites into orbit. Following the launch of Zvezda, the completed ICM was put into mothballs at NRL's Payload Processing Facility. In 2012, the module was proposed as part of a space telescope project. As far as we know, it is still in storage and supposedly could be ready for flight in several years, but there is a major obstacle. It was designed to be berthed to the station by the space shuttle, so it doesn't have the modern autonomous control systems found in today's resupply vehicles, and thus is very unlikely to be a viable contender for the deorbit role. In 2010, NASA's end-of-life disposal plan briefing to the Aerospace Safety Advisory Panel reflected the contemporary availability of the European ATV cargo craft. The presentation noted that a combination of the ATV in progress was under consideration, along with discussions with ESA about creating a dedicated deorbit vehicle. The early termination plan following an emergency evacuation called for sending additional vehicles to boost the ISS to a higher altitude to give controllers time to address the issue. 3 factors were cited as causing an early termination scenario: a catastrophic event causing a crew evacuation, the ISS cannot maintain control, and the event prevents vehicles from docking to the ISS. Later, a 2017 paper, co-authored by Russian and NASA engineers, emphasized that a quick decision to deorbit the station, within 2 weeks after a catastrophic event, would actually be needed, and the first deorbit burns might begin about 14 to 45 days after the catastrophe. The Russian service module avionics systems are only certified to be operational for 6 months in a vacuum, and the authors thought a micrometeoroid and orbital debris, MMOD, hit, causing, quote, irreversible depressurization, was the most likely terminating event. Crew evacuation could also be required for fire or ammonia leakage. So where does NASA plan to dump this marvel of space engineering, which weighs almost 1 million pounds? The Iss Cemetery location is known to NASA as the South Pacific Ocean Uninhabited Area, SPOUA. Others call it Point Nemo, and yet another moniker is the Oceanic Pole of Inaccessibility. It's considered the most remote place from humans on the planet, about 1,450 miles from the closest landmass. The National Oceanic and Atmospheric Administration says the nearest islands are Ducie Island, part of the Pitcairn Islands to the north, one of the Easter Islands, and Mare Island, part of Antarctica. There was one estimate that over 260 pieces of space junk have been deposited there since the early 1970s, including the Mir and Solute stations. The name Nemo, the Latin word for no one, refers to the name of the captain in Jules Verne's novels, including a famous submarine sailor in the book 20,000 Leagues Under the Sea. Ocean currents block large quantities of nutrients from this region, making it a relatively desolate area for ocean life. Even so, several biologists have expressed concern about polluting these deep ocean waters before any extensive biological surveys have been conducted. Marine life in that part of the Pacific includes whales, squids, sea stars, fish, crustaceans, and even octopuses. Last Tuesday at 12:49 a.m. Pacific Time, the Air Force successfully launched one of America's LGM-30G Minuteman III Icbms from Vandenberg Space Force Base. The flight is the latest in the continuing series of Glory Trip test launches. About 300 tests have been conducted in the program. The test was delayed twice, once in April to prevent any misunderstandings as Russia's Putin rattled his nuclear saber in conjunction with his assault on Ukraine, and again on August the 4th while China conducted military exercises around Taiwan. Here is a report from the USAF on the launch.
Air Force Global Strike Command airmen conducted an operational test launch of an unarmed Minuteman III ballistic missile August 16th to demonstrate the readiness of the U.S. nuclear forces and provide confidence in the lethality and effectiveness of the nation's nuclear deterrent. Today's test launch used a randomly selected intercontinental ballistic missile pulled from Minot Air Force Base, North Dakota. The missile was transported more than 1,300 miles and reassembled at Vandenberg Space Force Base, California. The Icbm was equipped with a test re-entry vehicle and traveled approximately 4,200 miles at a speed of more than 15,000 miles per hour to a test range near the Kwajalein Atoll in the Marshall Islands. The Icbm test and evaluation program helps validate the reliability of the nuclear umbrella our allies and partners rely on, eliminating the need to obtain their own nuclear weapons to counter potential adversaries. The 50-year-old Minuteman III is based in Colorado, Montana, Nebraska, North Dakota, and Wyoming. Reporting from Vandenberg Space Force Base, I'm Senior Airman Daniel Sanchez.
A replacement for the Minuteman is currently under development by Northrop Grumman. The three-stage solid-fuel missile is designated LGM-35 and named Sentinel. The Air Force plans to field the first missiles in 2029. By the way, for these strategic missiles, the letter L in LGM indicates that the missile is silo-launched. The G indicates that it is designed to attack ground targets, and the M shows that it is a guided missile. The Minuteman launch and the escalating threats from Russia and China remind us of the horror of nuclear warfare. A new study reports on the devastating impact such a conflict would have on the world's food supply. An international team of scientists, including a researcher affiliated with NASA's Goddard Institute for Space Studies, has estimated that more than 2 billion people could die from a nuclear exchange between Pakistan and India, while the toll from a massive war between the U.S. and Russia might reach 5 billion. Their report was published in the August 15th issue of the journal Nature Food. The threat comes from the injection of huge amounts of soot into the stratosphere. The soot is forecast to spread across the globe and cause rapid cooling of the climate that would last for decades. The analysis is based on the estimate that the India-Pakistan conflict would produce 5 to 47 teragrams of soot, while the Russian-American exchange would create more than 105 teragrams and a nuclear winter. A teragram, or TG, is equal to 1 million tons. Tracking of soot from recent major forest fires in Australia and Canada, according to the authors, added confidence to the computer model simulations. In a truly surprising development, SpaceX will now launch its second-generation Starlink satellites on Falcon 9 rockets. This is a dramatic departure from the announced intentions of Elon Musk, who has repeatedly stated that the so-called V2 satellite design was simply too large to fit on the Falcon 9 booster. It reflects the prolonged development time needed to make Starship operational and the immediate need to start populating the next generation of Starlink birds. Last year, a leaked email from Elon Musk emphasized the criticality of bringing Starship online as quickly as possible for its role in launching the larger and heavier V2 satellites. At that time, he warned that SpaceX could face bankruptcy if it did not implement the full Starlink constellation and its associated revenue. There was no public announcement of the change. It was disclosed in a filing on August 19th to the Federal Communications Commission, initially reported on the NASA Spaceflight website forum and on Twitter. The filing seeks the FCC's permission to proceed with Gen 2 constellation and outlines safety measures the company is implementing. The launch vehicle change is noted in this paragraph. Quote, SpaceX is proud to inform the Commission that it has decided to further accelerate its already record-breaking deployment schedule for its Gen 2 system by using both its new Starship vehicle as well as its tested and dependable Falcon 9. While SpaceX will use technically identical satellites on both rockets, the physical structures will be tailored to meet the physical dimensions of the rockets on which they will be launched. In no event will any satellite exceed the overly conservative analysis SpaceX provided to the Commission. To be clear, while SpaceX plans to accelerate deployment by using both of the rockets in its fleet, it remains committed to deploying all of its satellites, whether from Starship or from Falcon 9, into orbits described in Configuration 1 as described in its amendment from August 2021 and confirmed in its letter to the Commission in January of this year. Specifically, SpaceX plans to launch satellites for its Gen 2 constellation beginning with its 3 500-kilometer shells, followed by satellites in its lower altitude shells. The result will be that more Americans will receive high-quality broadband faster. The filing, signed by David Goldman, Satellite Policy Director at SpaceX, ends with this sales pitch. Quote, SpaceX has designed its Gen 2 system to be the most capable satellite constellation ever deployed for delivering high-capacity, low-latency broadband services with spectral efficiency and space sustainability at the forefront. With a complete record before it, the Commission should swiftly grant the Gen 2 application, enabling rapid deployment of next-generation satellite broadband to American consumers and businesses no matter where they are. Unquote. Satellite megaconstellations are recognized as a serious threat to astronomical observations, and in late July, SpaceX issued a 9-page paper entitled, quote, Brightness Mitigation Best Practices for Satellite Operators, intended to reassure the astronomy community that new measures will be taken to mitigate the impact of its newest spacecraft. It claims that its second-generation satellites will actually be darker than earlier craft because of the incorporation of 3 advanced technologies. The first is dielectric mirror film, which covers the bottom of the satellites and will be a second-generation material 10 times better at reducing observed brightness. It utilizes something called a Bragg mirror with multiple layers of thin plastic film. The document goes on to say that SpaceX will offer the film at cost to other satellite manufacturers. Solar array mitigations include an opaque pigment for the backsheet and a maneuver at terminator crossing to point the arrays away from the sun to minimize brightness. Finally, an internally developed low-reflectivity black paint, reportedly 5 times less reflective than the darkest space-stable paint, will be applied to complex components. In another milestone for Starship, a major Japanese satellite firm, Sky Perfect JSAT, issued a news release on August 18th announcing that it had selected the new booster for the launch of its Superbird 9 communications satellite with a GEO insertion in 2024. No further details about the contract are currently available. Starship is capable of placing about 20 tons into geostationary transfer orbit, while Superbird is only a fraction of that at about 3 tons. Industry observers speculate that SpaceX will implement a rideshare system for launches like this. The company is Asia's largest satellite operator with a fleet of 16 satellites. The satellite is being built by Airbus on its reconfigurable bus called OneSat and has Ku and Ka band links with a planned lifetime of 15 years. When the Airbus contract was announced in March 2021, the satellite manufacturer noted that it marked the first time a Japanese telecommunications operator had ordered a satellite from Europe. And finally, a tidbit about the Falcon 9 payload fairing recovery program. In a tweet, Musk reports that each fairing half is, quote, a fully capable re-entry vehicle with its own thrusters, thermal protection, avionics, and sensor suite. In the run-up to the Artemis launch, NASA has unveiled the first round of candidate lunar landing locations for the Artemis 3 mission, planned for no earlier than late 2025. The 13 regions are each 15 by 15 kilometers, or about 10 by 10 miles. Within each region, there are 10 or more pinpoint landing sites, marking 100-meter ellipses. The small site target is designed to allow easy access to favorable work locations. All the regions are located within 6 degrees of the South Pole, called a target-rich environment by scientists. Officials at the media teleconference and audio-only event noted that NASA is seeking input from the international lunar science community to narrow down the site selection, which should come about 18 months prior to launch. Here is a rundown of the site locations.
But the 13 regions that we're looking at are the rim of Amundsen crater, the northeastern rim of the Nobile crater. On the image, we call that Nobile 2. The western rim of Nobile crater, we call that Nobile 1 on the image. The Leibniz Beta Plateau, the rim of Falcini crater. There's an elevated region between the Shackleton crater and the Slater crater. The Malapert Massif. There are 2 locations along a high-standing ridge, and that ridge connects the Shackleton and the Dagerlosh craters. There's a location on the rim of Hallworth crater. There are 2 locations along the rim of Dagerlosh crater itself, and there's a massif between the Dagerlosh crater and the Coker craters.
Together, the regions provide landing options for all potential Artemis 3 launch opportunities. Specific landing sites are tightly coupled to the timing of the launch window, so multiple regions ensure flexibility to launch throughout the year. To select the regions, an agency-wide team of scientists and engineers assessed the area near the lunar South Pole using data from NASA's Lunar Reconnaissance Orbiter and decades of publications and lunar science findings. LRO is not currently in orbit that will enable any further imaging of these sites, however. In addition to considering launch window availability, the team evaluated regions based on their ability to accommodate a safe landing, using criteria including terrain slope, ease of communications with Earth, and lighting conditions. To determine accessibility, the team also considered combined capabilities of the Space Launch System rocket, the Orion spacecraft, and the SpaceX-provided Starship human landing system. All regions considered are scientifically significant because of their proximity to the lunar South Pole, which is an area that contains permanently shadowed regions rich in resources and in terrain unexplored by humans. Quote, several of the proposed sites within the regions are located among some of the oldest parts of the Moon, and together with the permanently shadowed regions, provide the opportunity to learn about the history of the Moon through previously unstudied lunar materials, said Sarah Noble, Artemis Lunar Science Lead for NASA's Planetary Science Division. The analysis team weighed other landing criteria with specific Artemis 3 science objectives, including the goal to land close enough to a permanently shadowed region to allow crew to conduct a moonwalk while limiting disturbance when landing. This will allow the crew to collect samples and conduct scientific analysis in an uncompromised area, yielding important information about the depth, distribution, and composition of water ice that was confirmed at the Moon's South Pole. The team identified regions that can fulfill the moonwalk objective by ensuring proximity to permanently shadowed regions and also factored in other lighting conditions. All 13 regions contain sites that provide continuous access to sunlight throughout a 6.5-day period, the planned duration of the Artemis 3 surface mission. Access to sunlight is critical for a long-term stay at the Moon because it provides a power source and minimizes temperature variations. Quote, developing a blueprint for exploring the solar systems means learning how to use resources that are available to us while also preserving their scientific integrity, unquote, said Jacob Bleacher, Chief Exploration Scientist for NASA. Lunar water ice is valuable from a scientific perspective and also as a resource because from it we can extract oxygen and hydrogen for life support systems and fuel. The issue of the composition of the first landing crew was raised at the teleconference. When the Artemis program was first announced by Administrator Bridenstine, it was stated that the landing would feature the first woman on the moon. Later, the Biden administration added that it would include the first person of color. Now, Mark Kirasich, Deputy Associate Administrator for the Artemis Campaign Development Division, has raised some doubt about the second goal.
We know on the first mission we are going to land a woman, and whether or not that woman will be a person of color or either of the two crew members will be a person of color, that's not a mandatory requirement for the first mission. Could happen. It could be one of the subsequent missions.
There were no representatives from Spacex, the contractor for the Starship-derived human landing system, at the conference. Questions about the capabilities and limitations of the lander were referred to the company, which has revealed little about the status of its design. On several occasions, it was noted that the design is incomplete and issues are still being resolved. The lander will have some manual controls, and the landing site selection for the SpaceX uncrewed demo flight, now penciled in for 2024, is the responsibility of the company, not NASA. It does have to be within 6 degrees of the South Pole, but there is no requirement that it be at any of the 13 candidate regions. The official said that Starship may also carry non-NASA cargo or commercial experiments on the Artemis mission, and they would not provide information on the disposition of the lander after it returns the landing crew to Orion in lunar orbit.
I think most space enthusiasts are familiar with Apollo views of the moon. Astronauts and rovers exploring fantastic features of the moon, features that are all bathed in sunlight as far as the eye can see. However, at the poles, the lunar seasons, coupled with an extremely low axial tilt for the moon of about 1 to 1.5 degrees, they yield a much different scene. At the equator, a lunar day spans roughly 14 Earth days of continuous sunlight, followed by about 14 Earth days of continuous darkness. That's on the order of 330, 340 hours of sunlight and darkness, repeated over and over. Nearly every place near the equator has a 50-50 split of light and darkness. During the daytime at the equator, you're completely in sunlight. You move a mile over there, 5 miles back here, you remain in sunlight. At the poles, the lighting is different. The ratio of light to darkness can vary significantly. It ranges from permanent darkness, locations that never see sunlight, to nearly complete exposure to the sun through a lunar year. What makes this situation even more complicated is that the ratio of light to darkness at any location, well, it varies over short distances. In as little as a few miles, sometimes even short distance like a football field, that ratio can be drastically different. While these sunlight conditions might sound complicated, thanks to LRO and our other spacecraft at the moon, these conditions are predictable. Although some locations might be dark most of the year, we will know when they are going to be in the light. While it might seem complicated, it's these very conditions that provide us with the rationale for going to the South Pole. Finding locations with greater than average amounts of light enable us to design systems that take advantage of light for energy and thermal control. Similarly, locations in permanent shadow, which are unique to the poles, provide opportunities for access to water and other volatiles that are trapped there, but they don't become stripped away by the solar wind. Although these conditions can be modeled and predicted, I think you can imagine many different technical considerations must be made in order to land here. Knowing that Apollo 17 would be the last Apollo mission to the moon, Apollo 17 astronaut Eugene Cernan reflected on his expectations. At that time he stated, The theme of our mission is that this isn't the end. We've just begun to crawl with the Apollo program. We're just now hoping that we can begin to walk as we press on into the future. Well, sir, we accept the challenge. Skylab, Shuttle, the International Space Station, they have all taught us how to survive and thrive in low Earth orbit. We're now ready to take that walk. Discussing the regions where Artemis 3 mission can land is our exciting first step on that path. We have to learn how to operate in some of these locations that are unique, of which, as you note, the permanently shadowed locations, they are certainly a unique aspect to the polar region. One of the things, I think Sarah noted this already, and I did earlier as well, these permanently shadowed locations may contain volatiles, frozen volatiles, in fact, that maybe we can go sample and begin to learn about. So we have a lot of questions about these permanently shadowed locations. What is the makeup, what is the relationship of volatiles and the regolith? What is the surface roughness inside these craters? Can we get down to the volatiles? Is there enough volatile there that we can actually sample it and or potentially extract larger volumes of it in the future? These are all questions we have. So the skill sets needed to do that will most likely fundamentally be, from a science perspective, understanding the geoscience aspects to it. So kind of your traditional field science skills we'll need to use there. But we're also going to have to learn how to operate in that total darkness on the lunar surface. So we do have questions about how much reflected light might go into these locations, and how do we actually navigate and work inside there, and actually how cold do they get at the scale of a person walking around. These are all questions we have. So permanently shadowed locations, regions, will certainly be a target of interest for us, trying to just understand them, understand what they hold for us from a science perspective and from a resource perspective, and in general, just starting to learn how to operate in there. So that's kind of what we're going to have to bring forward.
Yeah, and I can add to that, Jake, that it's not just operating in these permanently shadowed regions, but understanding how to do field geology in these extreme lighting conditions, even outside of these permanently shadowed craters, is going to be a challenge. And so we're actually practicing. We're, going out at night and doing analog activities where we bring our own sun and we test out the lights on the suits and make sure that our astronauts can actually see the geology that they're trying to study. And so we are actually already in practicing that and trying to learn how to do that and to optimize the situation for the astronauts when they get there.
Leo Enright, a veteran space reporter from Irish television, asked about the challenge posed by ever-changing lighting conditions at the sites. Here was the response.
Yeah, I'm still a little bit, I'm trying to get my head around these moving opportunities, because if you spool the image that shows us the 13 candidate landing regions is one instant in a 2-week cycle. And if you spool around with that video, only 2 of these sites are visible at any time. They all, they disappear into darkness constantly. So you're talking here about target regions, each one of which only has, it would seem, 4 or 5 days at most where they're fully lit. I mean, you're really trying to thread a needle here, and I'm trying to understand how you do that and keep an astronaut crew safe.
So this is Jake. I can start to answer that question. You are characterizing exactly the challenge that we're dealing with right now. And, as I mentioned in my opening, the Apollo missions took full advantage of the lighting conditions near the equator, knowing that they would have the equivalent of 14 continuous Earth days of light once per month. So they could land in those locations and know that they would have a stretch of 9-10 days of light. But you touched on exactly the difference with the South Polar region. Any of these locations is not in light all the time, neither were the equatorial regions. So we have to model and understand exactly when they do enter into light and for how long. And so one of the conditions we're looking at is that it would need to be in light for Artemis 3 throughout the duration of the mission. As Mark talked about, it's between 6 and 7 day long mission. So we need that stretch of sunlight, but that's really all we need. So it could be in darkness much of the rest of the time, but if it comes into light for that period of time at the right launch opportunity, we could go there. That's why we're looking at a number of sites, not narrowed down to a specific single one at this point. We have 13 regions, each of which include multiple sites. And as you said, we're trying to look at how we thread that needle. And then, as Mark said, how can we try to reduce that number from 13 down to a smaller number by better understanding with our modeling and also working with SpaceX to bring them into that conversation as well.
The issue of lighting conditions has figured prominently in planning. A presentation at the 2020 Lunar Science Workshop was entitled, quote, "Blinded by the Light, Illumination Considerations for the Artemis Site Selection, Traverse Planning, and Instrument Operations." The authors from NASA and supporting institutions said that the South Pole has, quote, "some of the harshest illumination conditions in the solar system," a rather daunting situation. They noted that the sun will always be within a few degrees of the horizon. The experience of Apollo astronauts was analyzed. It was determined that the expected sun position will reduce the crew's ability to see terrain details and slow mobility. Quote, "While we are not proposing that traverses only operate in the cross-sun direction, it will likely reduce wear and tear on the crew and the possibility of rover damage if time traveling towards or away from the sun is minimized. Apollo 17 utilized a tacking approach, minimizing the amount of time pointed up sun. Apollo crews utilized visors and sunshades on their helmets or a gloved hand to block the sun. However, in the case of Artemis, the sun may be much closer to the horizon, making such mitigations challenging. The use of opaque visors may improve up-sun viewing, at the cost of visibility of the surface, and when viewing across sun. Tomorrow will feature the first of our 10-part series, providing details about the fascinating CubeSat science payloads tucked into the SLS rocket, and will begin featuring in-depth previews of the Artemis mission. And that's the way space is today. Until tomorrow, ad in explorata toward the unknown in the measureless arena of space. Thanks for watching.